Hi, welcome to my video series where I'm going to go through Cracking the Coding Interview, which is a classic book on coding algorithms, and go through the different questions and solve them. Hopefully this will be useful. So starting all the way from Chapter 1, Problem 1, is unique, which can be found on page 90. So over here I print out the problem statement. Let me read it to you. So implement an algorithm to determine if a string has all unique characters. What if you cannot use additional data structures? Again, implement an algorithm to determine if the string has all unique characters. So basically, I'm going to look at a string, and that's going to be our input, and we're going to see if it has any repeating characters. If it has any repeating characters, then we know that it's not unique. So we're going to implement an algorithm to determine if a string has all unique characters and return false if it doesn't, and true if it does, if it's all unique. So let's just look at two examples of words so that we know what we're talking about over here. So let's say we have the word YOLO. So in this case, we'll return false because these are not all unique characters. You have the O over here, which is repeated. So therefore, this function will should return false. And let's say I do a different word like rad. So that should return true because all the letters are unique. Okay. So that's the problem, and I guess we have a few different questions we should ask when we see a problem like this, namely the constraints and the different questions about the actual problem itself. So one really good question to ask over here is, we're talking about a string has all unique characters. Now what character set are we talking about? Are we talking about the ASCII character set, which has 128 different characters? Or are we talking about Unicode, which has over 1 million? So that's a really good question to ask. And the answer for that question right now is we're going to talk about an ASCII character set where we only have 128, but I'm going to provide solutions that will work for both. Another question might be, are capital letters considered repeating? Like if I have like YOLO like that, is that still false? And the answer to that question is going to be that we're going to consider uppercase character as a different character. It's not going to be considered, it's going to be considered unique. So YOLO like this would actually be true. Okay, so let's actually add that. So like YOLO, like that, should return true. Okay. So those are just edge cases, and we might also want to consider like how big these strings can be. So let's say the constraint will be like 1,000 character strings, a maximum 1,000 character strings. Okay, great. So what are some solutions we can take to solving a problem like this? So actually identify there are 4 solutions, different ways to solve this problem of whether or not a string has all unique characters. So the first solution and is the brute force solution. And I'm going to write that over here, brute force solution. And the way the brute force solution works is that you have a outer loop and inner loop. So the outer loop looks at each letter, so it goes like Y, and then it will compare in the inner loop to every other letter in the string and see if it's the same letter. If it's the same letter, then we know we have a duplicate character, and then we will return that it's false, right? So when it reaches O and in the inner loop it sees another O, it's going to return false. So that's a brute force solution, and it's a really non-optimal solution. It's going to have big O of n squared because of the inner loop. Okay, so that's one solution. Another solution we can do, which is going to be more efficient, is we can sort the string first before we do any operation on it. So if we sort it, so let's say YOLO would end up being would look like this, and then once it's sorted, we can go and look at each character. We walk through the string, and then we look at the character we're looking at and the character after it, and just see if, or if the character after it is the same as the current character, and if it is, then we know that there's a repeated. So basically, so sort first, and then walk through, through it. And classic sorting, optimized sorting algorithm would for this case run n log n, and then the walkthrough would be O of n. So in the way that we do amortized analysis is O n log n for a sort like this. And if you notice that both these actually don't use any additional data structure, they just manipulate or operate on the data itself. So that would be the answer to what if you cannot use additional data structures. So in this case, the best would be O n log n, where you basically you sort the string first, and then you walk through and compare each character to the next. Okay. A third option is to use a set or a hash map. And the way the set or a hash map would work is that as you walk through the string, you add each character that you see to the set, and then you also check whether or not the character already exists in the set. So for, let's say, YOLO, right? So Y, I would check the set. Oh, it doesn't exist. Okay, add to the set. I go O, I check the set, doesn't exist, add to the set. L, same thing, add to the set. And I see the final O, and I'm like, I check the set, and I see that it already exists in the set, so therefore I know that it's already been encountered, and therefore we know that it has a duplicate character. Okay? And that would work great for, like, if, let's say, our set of characters, possible characters, was Unicode, and you could have over 1 million different possibilities. So in that case, we would use a set or hash map, and that would be like an efficient way of storing every time we encounter a unique character. And a thing like this would be O of n, as far as runtime. And as far as space complexity, it depends on the size of our alphabet, basically. So it's basically the size of our character set. In ASCII, that would be 128, which would essentially be constant. Okay? Because we're not talking about like an infinite size character set. But in Unicode, maybe you'd want to represent it as a big O of C for space. Okay. So that's the set hash map, which is a very versatile solution. Another solution, though, which can apply especially in our case over here, since we're talking about a limited 128 character ASCII, we can create an array of booleans. So I'm going to say a boolean array. And the way this works is that every single character has an ASCII code representation, and that will be an index into the boolean array. And the boolean array initially will start as false. And as we see each letter, we flip the corresponding index to true. And then if we encounter it again, we recognize that it will already be true in the array. The Boolean value will already be true, and we know we've already encountered it, and therefore we know that the string is not all unique characters. Okay? And I'm going to show you how to implement that in the algorithm that we're going to implement. Okay? So Boolean array, that would also have O of n runtime, and it would actually have constant space because we're just talking about a character set, a Boolean array of 128. I know with Python the array would not in certain languages you can implement something called a bit vector, in which case you're literally just taking 128 bits because each bit will be a 1 or 0, and that would be even like a smaller than a Boolean array, but it depends how under the hood Python implemented the Boolean array. So let's approach this problem now that we have 4 different ways to solve it, and the Boolean array is the one I'm going to choose over here to implement our solution. I'm going to show you how to do that. Okay, so let's name this function is unique, and this function is going to take a string. Okay, great. So the first thing we're going to do is we're going to create this array, this Boolean array. So I'm going to call it array. That's R for array. And I'm going to say it's made up of false elements, 128 of them. So that's our initial array. Great. So what's our next step here? So our next step is to go through each of these characters in the string, and first of all, as we encounter them, flip the value in the array to true. And if we re-encounter them, then we can return that the string is not unique, and we can return false from this function. Okay, so let's do that. So for char in string, I'm going to first I need to find the Unicode representation of this character. So Python actually has a great function that's already built in. It's called ord, and ord will let us know what that value is. So I'm going to say index equals ord and char. Okay, and that's going to get us the ASCII value for the char. Okay, great. And now we can do if array index, if that's true, then return false. Because basically, if it has been set to true, if in that Boolean array that index is set to true, that means we've encountered it before. How do we know we've encountered it before? Because right over here, we're going to do this line right over here. It's going to be array index equals true. Okay, So basically the first time we encounter it, it's going to set array index to true. And then if we encounter it again, it's going to return false. Great, and that's literally all we have to do. And then at the end, if it makes its way through the entire thing and it never hit this return false statement, then we're going to just return true. And basically that would mean that this array is indeed, this string is indeed unique. Okay, let's run, let's make a test case over here so that we can make sure that this actually works as we were intending, as you should always do at the end of interview or like walk through, you know. So let's check this out. So print is unique, and I'm going to pass in the string YOLO, and I'm going to expect that to equal false. Okay, let's make another one. We're going to expect rad to equal true as being unique, and then we're also going to expect YOLO like this to equal true, to be unique. Okay, let's run this, see what happens. And you see over here that all of these test cases return true, which means that they all worked out, that they all produced expected values. So it definitely appears that this works. And I want to point out one more trick that we can do if, you know, for bonus points over here, is that we can recognize that since there's only 128 possible characters, that if we are provided a string that's larger than 128, then we know automatically, without even running through our rest of our program, that there's got to be a duplicate character. Okay? So we can do that, and we can add that, and that would actually make our runtime kind of a constant. Yeah, well, because basically n would be at largest 128. Because even if you provided a string of 1,000 characters, if it would automatically immediately say that that's false, that it's not a unique string. So let's just run that check over here. So if the length of the string is greater than 128, so then return false. And that way, we're basically, even if we're provided a very large string, you know, it would return false immediately. So at largest, this can process 128. So it's really O of 128 at maximum. So that would be the runtime. So very efficient way to do this problem. Anyways, thanks for listening. And by the way, if you want to do the setter hash map, I'm considering making another video for that. But basically, that would as I said, you'd add it to your set, or you add it to your hash map, and then you check if it's in the hash map. Okay. So yeah, I hope this was helpful, and I hope to do more videos all the way from chapter 1 through 5 and from 7 through 10. Hope to see you soon. Thanks.